Linear regression. You may have heard this term before, linear regression. And what is linear regression? Well, linear regression is a fairly simple mathematical tool to fit a line to data. And it's a way to estimate a linear trend or estimate a linear equation. And linear regression equations are generally going to look like this. First, we have the y. The y is the outcome, also called dependent or response. There's many terms. There's even more terms in this. Outcome dependent response variable. It's usually plotted on the y-axis. Alpha here, sometimes called a B0, beta 0, is the y-intercept. So this is where what the value of y is going to be when x equals 0, and also if the error equals 0. We'll talk about this error here at the end. This b here is beta, and it's the parameter to be estimated to determine the value of the outcome variable. Parameter to be estimated from the data. And x is the data point. And then the epsilon is the error term. Because usually when we fit a line into data, all the points of the data are not going to fit perfectly in the line. So there is an error or a residual. And the one here is just that when we use linear regression, we can often expand to multiple parameters. So this one should be like a small one here. It's not actual one that we're multiplying with. It's just the first beta, or the first parameter. So let's take a look at some examples here. Often when we have data in any kind of a linear trend, it may look like this. And here is a negative linear trend. So as one x goes up, the y goes down. Here we have a positive linear trend. As x goes up, y goes up. And then here it's kind of a little bit ambiguous, but well, supposedly they estimated, and it looks a little bit negative, but very close to be flat. And so what the linear regression does is estimate the slope of the line, and create a line that best fits the data points, the trend of the data points. And as I've shown before, this will be with an equation that looks like this. Sometimes the y-intercept is maybe called alpha or a, and then we have at least one parameter for one variable. And if we have more variables, it would look something like this. B1x, and then we actually number the variables as well. So this is x, maybe 1, and then plus b beta 2 x2, and so on. So we can actually have multiple parameters with multiple variables. However, it's very difficult to graph this, so we usually begin examples just with one to facilitate understanding, and also because it's difficult to graph multiple parameters and multiple variables on paper or on a flat screen. So that's the main idea of linear regression, and that's the equation that we use for linear regression. Note that depending on how the data is shaped, there's no linear trend, right? So trying to find the line or the equation of a line to it is just not going to make sense. So linear regression is for cases when we apply to cases when the data points of the data itself show a linear trend or expected to be linear. And as we'll show, the parameter, the x, are the data points, and the parameters are estimated from the data. The parameters are estimated from the data, and we're going to take a look at how to do that in the next example. See you there.